All right, we are going to talk today about multiplying polynomials. And in our notes, we have several different scenarios here we need to talk about. So the first scenario is when you have a monomial, so a one-term polynomial being multiplied by a binomial. Now this is very easy for you guys. This is I don't want to say a review, but it really is. You've dealt with this before. It's the famous old distributive property where you multiply whatever is outside the parentheses by everything inside the parentheses. So in this case, you have 2 times 5 is 10. M times m is m squared. Then you take your 2m and it multiplies by the 2. It stays positive for m. And then you check to see if you have any like terms to combine. In this case, you do not, because this term is an m squared, this term is an m. They are not identical, therefore you cannot combine them. Now, the next example is we scroll straight down as I went from 1 to 3. We take a look at number 3 here. You have, again, a monomial has one term, but now we're multiplying to a trinomial, which has 3 terms. Well, the process is the exact same. We are going to distribute the 4r through. So the first term here is 4r times 2r squared will give me 8r to the third. 4r times negative 6r is negative 24r squared. And then lastly, 4r times 6 is a 24r. And again, you would look to see if you have any like terms, and you do not. Nothing to combine here because you have an r to the third, r to the squared, and an r. There's nothing there to combine, so this is your final answer right here. Now, as you take a look at number 5, as we again continue to scroll down the left-hand column here, on number 5, we have 2 binomials multiplying by one another. Now, there is a way to do this where it is literally just the distributive property twice. That's the technical way to do this. You were probably taught the 4-letter F word in math, which of course is FOIL, where you do first, outer, inner, and last. Okay, but I actually have a way that I think is very student-friendly because it forces you to stay organized. And as you learn from your unit on exponents, staying organized is very critical to making math very easy. So the first thing you're going to do, I call this the box method because you're literally going to draw a box, and you're going to draw it and cut it up such that it is in 4 squares. Take your first term, so your 6n plus 3, and we are going to put the 6n above this column and the 3 above this column. And then we're going to take our second term, and we're going to put the 6n across this row and the 2 across this row. Now, the name of the game is you will multiply these 2 numbers to get the value in this box. You will multiply these 2 numbers to get the value in this box. These 2 numbers to get the value in this box, and these 2 values to get the value in this box. So to take a look at this, we have 6n times 6n. All right, well, 6 times 6 is 36. N times n is n squared. Now, it doesn't matter which you go next, if you go to the right, if you go below. Let's go below. Now we have 6n times 2 will give me 12n. Moving along here, if I want to operate and get into this section of the box, 6n times 3 is 18n. And then finally, to get the lower right-hand corner of the box, 2 times 3 is 6. Now, this isn't our final answer. We have one last step. And what will always happen at this point is you just want to go ahead and combine your like terms. However, if you always set your box up this way such that your like terms will always be in the bottom left, top right diagonal. And as you notice, if you don't like that, or if you're uncertain in any way, simply just look, okay, are there any n squareds inside the box? Just the 36 n squared, okay? Are there any plain old n's in the box? Well, there's a plain old n to the first here and an n to the first here. You're combining. They're both positive, so in this case you are adding 12 plus 18 is 30n. And then finally, we have our constant term, which is simply just 6. Okay? At this point, you are finished. Again, if you notice, I have my answer written from highest to lowest exponent in standard form as you had learned the past 2 days. Always write your answer from highest exponent all the way down in consecutive order to the lowest exponent. Scooching on down to number 7. All right, same thing. We have a binomial times a binomial. So make a box such that it is 2 by 2. There's 4 total squares in here. And 6x plus 1 goes across the top. 3x plus 3 goes down the left-hand side. It does not matter which one you put here and which binomial you put here. It really doesn't matter. You're multiplying, and as you know, multiplication order does not matter. So if I want to work top left, 6x times 3x is 18x squared. Bottom left, 3 times 6x is 18x. Top right, 1 times 3x is simply just 3x. And lastly, 3 times 1 is simply just 3. And again, because of the way I set this up, my only like terms are on the top right, bottom left. Nevertheless, I just double check. 18 x squared is the only x squared inside the box. I obviously here have a 18x and a 3x, which combine to give me 21x. And then a plus 3 there on the end. That is my final answer. Okay. We have one final example that I will do, and the only difference in this one is you have a binomial being multiplied by a trinomial. No big deal. You just need to make more of a, I guess, rectangle in this case than you do a square. And you want to cut it up such that you have 2 on this side, 3 on this side, and obviously I think you know which term is going to go where. So the 8n and the negative 1 will go down the left-hand side because that's where my 2 boxes are. And across the top, 5n squared, negative 8n, and minus 4. The process is the exact same. 8n times 5n squared. Now this just got to be detailed here. 40n to the third. Our property of exponents tell us to add exponents when we multiply like bases. Bottom left, I will get, oh, my pen died. Bottom left here, we're going to get 5n squared times negative 1, which is negative 5n squared. If I go to the top middle, negative 8n times 8n is a negative 64n squared. Bottom middle, negative 1 times negative 8 is 8n. And lastly, negative 4 times 8n is negative 32n. And negative 1 times negative 4 is a positive 4. Now, as we go through to look at our like terms here, the only n to the third term is that 40 n to the third. There are no, within the box, there are no other n to the third terms. If you pay attention here, I still have my like terms on the diagonal, okay? But again, you're just combining your n squareds together, you're combining your n's together, and you're combining your constants together. Well, in this case, negative 5n squared combined with a negative 64n squared combines to give me a negative 69n squared. If I take a look at my n terms, n to the first terms, 8n plus negative 32n is, again, when I combine them, is a negative 24n. And then finally, I have this 4. There's no other constant terms in the box, so when I combine it, I just have a positive 4. And again, my answer is written in order from highest to lowest for my final answer. Your homework tonight is to complete all of the even questions. All right, we will reconvene, and I will answer all questions when I see you guys all on Monday. Have a wonderful afternoon, and I will see you all soon.